Welcome to the first module, which is an introduction to this whole TDA-SAP process. Some of these slides I will go over quite quickly, but others I will spend a lot more detail and time on. And again, feel free to just interject when you want, if you have questions. So in this module, we're going to learn about something. How many of you know about the Global Environment Facility? Okay, so some of you do. How many don't know about the Global Environment Facility? There's a few people that say, okay, that's fine. Good, okay. So we'll just talk very, very briefly about GEF. Then I'm going to go into a bit of detail about international waters in the context of GEF. So why does GEF look at international waters? Why are they so important? And you probably know lots of this anyway. Then we'll go into the TDA-SAP process, and then we'll discuss some of the TDA-SAP principles. So firstly then, GEF in international waters. So GEF stands for Global Environment Facility. So it's the largest public funded of projects to improve the global environment. It has historically had a very large budget, and we'll talk about it in a moment. What it tries to address are global environmental issues, but also trying to support national initiatives, sustainable national initiatives. So predominantly it's focused on my microphone. Predominantly, it focuses on global issues. So those are the issues that are going to be transboundary in nature. And so it provides grants for projects relating to biodiversity, climate change, international waters, land degradation, ozone layer, and persistent organic pollutants. So this project, the HCLME project, comes under international waters. All of these areas that I just described here have a convention associated with them, apart from international waters. So there's a biodiversity convention, there's the POPs convention, there's one around desertification, and there's the ozone one is the Montreal Protocol, there's the Kyoto Protocol for climate change. So they all have conventions apart from international waters. All these areas are funded by GEF. And this project, I said, comes under international waters and is funded by GEF. So since 1991, it's provided in the region of $10.5 billion in grants to projects all around the world, and it's leveraged around $51 billion in co-financing over about 2,700 projects in 165 countries. So it has a global reach, and in terms of international waters projects, it covers LMEs, like this one, like Gulf of Mexico, like the Guinea Current Artery Ecosystem, the Canary Current, etc. So all the LMEs. It also covers rivers, river systems. So one of the very early projects was the Danube, but Amazon, the Rio de la Plata are rivers in this region that have had GEF interventions in terms of projects. Lakes, Lake Chad in Africa is an example, and aquifers. The Guarani aquifer in Latin America is kind of local to here, but also very large aquifers in Africa have also benefited from funding from GEF. And it's also made more than 14,000 small grants directly to civil society and community-based organisations, totalling based on the information that I've been given, around $634 million. So it also funds small grants as well. So that's basically what GEF does. GEF is a funding body. The money that GEF gets comes from many of the donor countries, and then predominantly GEF funds projects that are in developing or transition economy countries. Okay. So that's what GEF is. So what are international waters when we're talking about GEF? GEF international waters are transboundary water systems. That's what it's looking at. We're not really talking about here about international law of the sea, particularly. We're not talking about UNCLOS, the UNCLOS definition of international waters. It's much broader than that. Although, of course, UNCLOS is involved, is part of this as well, particularly when we're talking about marine ecosystems, large marine ecosystems. But when we're talking about transboundary water systems, I've already mentioned these, we're talking about river basins where flows go from one country to another. So let me get a whiteboard over here. So this is the river flowing into the sea, and it could be one country. So there could be a number of different countries associated with a river system, water's flowing in that direction. So in this instance we've got particularly problems that are associated, that occur in upstream countries, but the consequences are downstream. Okay, so that's a classic river system. It could be also multi-country lake basins, which in essence are a bit like freshwater LMEs. So a lake, and it could be divided up. So we have a number of different countries around the lake, all impacting or having or causing problems in that particular lake. So that's a classic transboundary lake. Groundwater resources can use the same diagram essentially. If we just put lines across, it could all be sharing the same aquifer, and some problems over pumping here may result in loss of groundwater in another country, for example. We'll talk about this in much more detail as the day goes on, but just to give you an idea, okay, that's another transboundary water system that Jeff is interested in. And then of course LMEs. You're working in LME, so you all know about LMEs. So I don't necessarily need to go into detail about that. But these could be coastal waters, they could be LME waters, but they're all with a marine context. Okay. So transboundary waters then are water systems that are shared between one or more countries. In this instance, in the Humboldt Current, there's 2 countries in this project. But other LMEs, the Guinea Current large marine ecosystem, I think there was 19 countries. So much more complexity, many more countries. The Lake Chad, I think it's 5 countries. The Rio de la Plata project, the Maritime Front project, is just Uruguay and Argentina. But in all instances, it is about water systems that are shared between more than one country. And transboundary waters cover what are known as boundary water resources, where the boundary between 2 or more sovereign states is formed by an LME or an international lake or river. In essence, this is what we're talking about here. or successive water resources, where an international river flows from one sovereign state into another. Okay? Does everybody get that? My very bad drawings over there are shown here. So again, LME, a marine system shared between 3 countries, a river basin shared between 3 countries, a lake and an aquifer. Okay. And these are all in the notes. I should also point out that all the materials that you're seeing here today, the Spanish translations and the English, will be made available to you electronically afterwards. So, that's a very bad slide. Doesn't come out very well. So why are they important? This is Latin America. Well, this is Latin America. The US is up here somewhere, and Europe has kind of fallen off this. It's, taken from me, it was a picture of the globe, and is showing international water drainage basins. But why are they important? Nearly half the world's population is located within one or more of 263 international drainage basins that share between 2 or more states. Furthermore, at least 145 nations include territories within an international basin. At least 21 nations lie in their entirety within international basins. 33 countries have greater than 95% of their territory within these basins. 19 international basins share between 5 or more riparian countries. The Danube alone, in Western Europe, has 17 riparian nations, so 17 countries in one river basin. The Congo, the Nile, the Niger, the Rhine, the Zambezi share between 9 and 11 countries. These are big water systems that are predominantly shared between more than one country. And it goes on. 64 LMEs produce 95% of the world's catch. And as I understand it, this LME produces 20% of the world's catch. So these are hugely important, hugely globally important. They're not just important for Chile and for Peru, they're important globally. And that's the big issue here. One of the issues. So,